This is House Planning Help episode 282. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build, because I'm exploring what houses we should be building in the 21st century and trying to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Nick Grant from Elemental Solutions, and we're going to be looking at sharing knowledge, testing and debunking, and numerous other things. This podcast is not a straight line today because I throw all sorts of things at Nick. Nick is also the technical director of the Passive House Trust. And this episode came about from a presentation that he gave his good friend and another great technical mind, Alan Clark. So Nick and Alan, at one point I did think about doing this podcast and getting them together, but my goodness, they're busy people. They don't exactly live right next door to each other. So it just wasn't going to happen. So a hat tip to Alan. We're thinking of you. And this presentation was looking at the 30th anniversary of the AECB, reflecting on things that they've got right during this time and also those that perhaps they didn't, and just being honest. And there was a great warmth to this, obviously a lot of memories over the last few decades. And I always feel like I'm in the right place. You know, I try to mingle with the organisations that just this feels right, and the AECB is right up there. So if you're not aware of them, go and check them out. We'll definitely put a link into the show notes today. This is a casual discussion, as I mentioned, so we'll be jumping around quite a bit. But we'll start with just knowledge sharing. The construction industry in general can seem stuck in its ways. So I was asking Nick about why it's not always straightforward, for everyone at least, to improve and grow.
Yeah, no, I think it's interesting. I was just reflecting on that a bit. Also how different disciplines like engineering, any of the sciences, they're always moving forward and there's feedback and every year it gets better. Whereas in architecture, I don't think things necessarily progress as such. In the AECB, there's been a openness to critical thought and accepting that you're wrong and realizing mistakes made and learning from each other's mistakes. And I think that's strong in the AECB.
How do you do that, though, to be that open when it's probably fighting against a natural instinct?
Yeah, no, it's hard. I think it's easier for smaller companies and sole practitioners and so on, because if you're in a bigger organization, if you suddenly decide to do something differently, then there's a lot more inertia in the organization. You might be committed to certain standards and guidelines and so on, which challenge those. Whereas if you're sole practitioners or a smaller practice, you can question everything and be more open to making changes, I think. But it's difficult. I mean, the example we gave at the AECB talk was rainwater harvesting, which Alan and I had both been involved with. We'd written software, we'd optimized tanks, so we really got into it. And that's the other thing. A lot of us are real geeks and nerds, and we kind of love solving problems and getting into things. But then you realize that suddenly that it doesn't make sense on some level. There was various things came together, looking at life cycle assessment. The economics we always knew wasn't good, but then we sort of thought, well, it's instead of having an expensive fitted kitchen, you do something green. But then we sort of thought, well, if you've got that money free, you could do something else more green and so on. So there was a whole load of things came together, and that was quite hard when you spend maybe 5 years of your professional life developing something, pushing something, becoming known as an expert in it, and then suddenly you think this doesn't make any sense. Biomass, like we did our house, again, another example we've used in our house now, we designed it around the idea that heating with wood was very low or almost zero carbon. So that led to certain design decisions. And then realizing some years later when we were struggling with the maths of if the energy source is zero carbon, why save it? Why use insulation? Why use heat recovery ventilation? It didn't make sense if you're trying to save something with no impact, which that led to the AECB biomass paper and so on. So some of these things, they're better to know than not know, because you could carry on the rest of your life till your grave doing things that turned out to not be worthwhile.
And that too, I have to give you a lot of credit for things like that. I remember you perhaps saying on Twitter, you'd had a stiff drink that night when you come to that realization. So being able to put assumptions that you've had for a long time and then to change your mind. Do you know, that's like a big thing, isn't it? When you've...
I mean, it's something, I'm not a scientist, I'm not even an engineer properly, but that's my background. But in science, there's some quote by someone saying that if you're shown that you're wrong, then you should really celebrate that and welcome that, because it's a positive result. So learning negatives is, in fact, it's if you can get rid of all the negatives, then what's left is the bit you want. So, it's quite useful. It's like weeding out the dross, editing things out. So, yes, to be welcomed, really.
We're all on a journey of learning how to produce better buildings. And that's what was fascinating about this talk, was to take it right back to, say, simple things that insulation that in your early days, you were just starting to insulate on the slab and things like that. Whereas to me, coming in today, that would be instinctive.
Yeah, I mean, a lot of things, well, it's interesting you use the word instinctive, because when we designed our house, we'd heard of passive house, but there was nothing really in English, and we just knew the concept, and we knew that it was about thermal bridges and air tightness and so on. So when we designed our house, we didn't do any energy modelling, because we thought, what's the point? We've got the walls are over a foot thick, the insulation in the roof is over a foot, there's no thermal bridges, it's intuitive. It was intuitively designed. It's only when we modelled it later that we realised that actually it was really not great, and that was particularly because of the form, and the form factor, something, again, it's a term that's now getting used quite a lot, and that's the heat loss area relative to the useful floor space. So we've got quite a complicated shaped building, which means it took a long time to build. If we'd have paid someone else to build it, it would have cost a lot of money, but because of that form factor, and it's not intuitive, how much difference that made. We didn't get it, and it's only by doing the analysis now. But having done that analysis on hundreds and hundreds of buildings, we now have a sort of learnt intuition. So, like you say, it's second nature to think continuous insulation and good thickness of insulation. Then some of that stuff wasn't yet learned. Like thermal bridges, we just didn't. It wasn't in the building regs. We knew it as a term, but we didn't realise that maybe a third of your heat was going through the thermal bridges if you didn't sort them.
Can you remember the moment when seeing Passive House and looking behind the scenes, but at all the physics, where you thought, hold on a second, SAP is not doing the same thing?
I don't think there's a moment, but the moment, if there is a moment, friend Chris Herring and I went to Austria to the first Passive House conference we went to in Bregenz in 2007, I think. And I kind of went a bit to debunk it, because in the AECB there was a discussion going on at the time. Passive House had been mentioned. There were people who were looking into that, and this idea of learning new conventions and different methods, like having to use external dimensions instead of the internal dimensions we use in SAP. Then others, we were looking at improving SAP, because ultimately there's no magic to Passive House. It's just a standard model. It's the same physics. Just certain things, it puts more attention on certain things that have been found to be important, and the thermal bridging and so on, which it took all that into consideration. So we're going out to Austria, and partly, I say, to debunk it a bit, having sort of had the experience of rainwater harvesting and following that for years, and then suddenly realising it didn't really stack up, and biomass and others things. I was sort of going a bit to debunk it, but partly out of curiosity. Then came back thinking, having seen some buildings, seen the talks, thinking, look, this actually works. There's things we can change about it, but we're not going to have to. We don't have to reinvent stuff. This actually works, and very impressive what we saw. And
why do you feel it's such a core part of sustainable building?
Yeah, well, again, I feel I never like being sort of tied to one thing. I sort of feel apologetic about being, and when I'm in Passive House circles, we're always looking for things that are wrong, things we can fix, and we're very unevangelical about it. But when we're teaching the course and when we're working with architects or potential clients who are looking to build, then we pretty much just say, look, it works. Don't worry about the details. For years, we'd argue about things like thermal mass and all sorts of discussions, which were almost sort of points of opinion. It's a bit like before Google, when you'd wonder about something down the pub and you think, well, maybe we'll never know. And now someone just gets the phone out and checks it. So we've got a simple model we can use. We've got people we can talk to. There's a whole community. There's buildings that have been built. So a lot of these things, which were sort of mysterious, questions, that we've got answers now, and it's.
You've mentioned the word debunk a couple of times in this chat, and I thought that was something that was quite interesting in your talk. You gave an example of the Cork House as it's a lovely building in itself, but it's never anything that could be rolled out at scale. But you could make that assumption of thinking, great material, let's build everything like this.
Yeah, I think, and again, the AECB, that's been a key thing. It's this critical thinking. And questioning stuff, we question the stuff that we're doing. So, and that's a skill. It's something that should be taught in school. It's a fundamental principle. Learning, if someone's trying to sell you something you know nothing about, how do you work out if they're telling the truth or not? You're not going to go off to university and study it for 4 years just to be able to answer whether that thing is nonsense or not. So you need certain ways of spotting things. So things like the cork house, you suddenly see that, and the first question is, how much cork is there? Because it's a lovely material. So 5 minutes in Google, and we get some very quick answers. So there's rough and ready results, and that's something again when we teach the passive house course, the building physics stuff. We try and get across those ideas that you can do stuff by hand. You can work out what difference this material or that material. Does it matter if there's this thermal bridge or if the insulation's changed to a different grade? Just very fag packet calcs, and that just learning that can be done without demystifying, I think. So that critical thinking.
But a lot of people skip that step. So why?
I don't know why. It could be human nature. I don't know. I mean, some things you don't want to know. It's like, one of the big resistances, I think, with building designers about passive house and building physics in general is not wanting to have constraints. So if we do the sums and work out the building's going to overheat or it's going to use lots of energy, then because of the shape particularly, or the glazing, because they're kind of key visual things which the designer might be very passionate about. So if you're designing something from the outside in and you've come up with a shape and fenestration, and then the analysis says it's not going to work, then I think there's a lot of resistance to that.
Reinventing the wheel is one of those things that seems to happen time and again. So another question here: why? Is it our need to be the person that came up with this idea?
Yeah, I think. It's interesting. It was particularly with building standards, because there's a perception that passive house, well, it is. On one hand, it's this open source thing because it's transparent, it's out there. There's no reason why you can't copy it. It's not trademarked or anything like that. But if you're going to certify, then that has to be done by the Passive House Institute. If you want to change the software or change anything that's regularly called Passive House, then you kind of have to go through that process. So in that sense, it's not open source. So there's a tendency, if you want to come up with an energy standard for your country, then there's a reason there to have to sort of make your own version, if you like. So that's one reason. But otherwise, I think it's people trying to do something different, or they maybe see I really don't know the answer, but it seems to keep happening.
If someone came in today, someone fresh to architecture, fresh to engineering, whatever it might be, do they pick up on Passive House and start their learning journey there, or do they have to go through all of these things that naturally you have done over the last few decades?
Well, it's a good shortcut. So when we teach the course, although it's really just building physics, it's called Passive House. It's to the exam, the Passive House Designer Training. But that is a good grounding in basic building physics. So I think that's a good shortcut, because you could head off down, see people doing stuff we were doing in the 80s and reinventing thermal rock stores and phase change walls, all sorts of stuff. And sometimes you see this stuff in student projects, for instance, and there's a bit of a sort of head in your hands thinking, oh God, we tried all that in the 80s, it didn't work, or it worked, but it was ridiculously expensive and you don't need to do that. So I think start with something that works. I've never managed to learn music, but part of me would like to just be able to pick up an instrument and improvise and play. But I know you've got to learn other people's stuff and you've got to go through that whole seemingly boring process, but then you can be free and do your own thing. And I think it's a bit like that. If you learn the basic tools and learn something that works, and then once you've done that, you built something, then you can see where change is needed.
And quite often I've run into this as well, that you seem to have people in two camps, one who go down the building physics, the energy efficiency route, and then the other that are out with straw bales and building that way. Is there a reason that it doesn't meet in the middle?
It's interesting you pick those camps. I think there are a lot of camps, but certainly within Passive House, as you know, George, just down the road, he lives in a straw passive house, and a very good friend in Slovakia, Bjorn Kirulf. So he's doing Passive House and he's doing straw and mud and natural materials. So I don't see the camps split along building physics, natural lines, although that has been a case in the past. In the AECB early days, there was more of a sort of natural materials, and some of them, like mud and cob and so on, is thermally not very good. It's not a good performing thing. So that did lead, if you're going to go down that route, you kind of had to abandon the performance side. So you tend to justify in other ways. You'd talk about low embodied energy, and you'd justify the greenness of your corner by looking at certain aspects, whereas it's not necessary.
Does one have to lead, though, almost, that one aspect? So you're led by the building physics approach, and then if you've still got the money left over, then you can have because often the materials, let's say on George's one, for example, he's using clay plaster, and I know he's done it all, so perhaps he's a bad example, but do you see what I'm saying there?
I think it's a good example, but this idea of what you prioritize, it's almost a problem when you start to talk about energy. We've been in conversations where we're talking about thermal bridges or something like that, and immediately someone pipes up saying it's not just about energy, but you can only talk about one thing at a time. So, if you're talking about thermal bridges, it seems like you don't care about the colour of the paintwork or the softness of the corners and the reveals or the texture of the plaster, but you can care about all those things, but it's only possible to talk about one at a time. I think the problem is when you pursue one and it causes a problem for the others or excludes the others. So if the energy performance requires things that are ugly or polluting or something like that, then that's a problem, but that's not what I'd want to do. There's a quote I'm always using in talks of Charles and Ray Eames about the difference between compromise and constraints. They're saying they've embraced constraints, but never aware of having to have made a compromise. So I see a big difference between constraints. So your constraint might be budget. You might decide the constraint is you want to use materials within a certain radius or materials with a very low embodied energy. You can set any constraints, but you still need to make it sort of operational energy is low and comfort is good and performance and fire and everything. You've got safety, you've got to do all those things. So, yeah.
Will Passive House, do you think, go down that road of looking more at embodied carbon?
Again, it's interesting. We just, Bill Butcher and I just did a couple of days at CAT. And when we sort of said the stuff we're going to do, we mentioned embodied energy and some examples of buildings, and the feedback we got was, oh, great, at last Passive House is looking at embodied energy. And there's nothing to stop. And it's like saying, oh, at last Passive House is looking at fire regulations or, daylighting. It's just another thing you do. But if you make it part of the standard, then I think you end up down a complicated route. I'd rather it was kept as a separate thing, because otherwise you end up potentially with trade-offs. So we see a lot of green building standards. If you've got lower embodied energy, then you can have slightly higher operation, or if you've got more cycle racks, you can have less bat boxes. So you kind of got to get so many points, and it's daft. You end up doing silly games. So if you need cycle racks,
I just say that because people are always wanting to try and go as sustainable as possible, and it does seem that if you put all your eggs in one basket, then you forget about life cycle or something like that. And I wonder whether all these things are converging, or whether maybe it doesn't have to. All the buildings that we're talking about will be far, far better than the vast majority that are built in this country.
And I think it brings up the point of how much stuff you've got time, effort to work at on the design stage. So a lot of stuff would be nice if it was sorted at the building product level, so that the energy performance of goods or heat recovery, ventilation, so on, you shouldn't have to sort of do a market research on every building to check. That stuff needs to be sorted out, so it's impossible to buy stuff that doesn't work. I mean, that's what we want to do. Same with materials, if we've got a really clear guide. But I think the problem with embodied energy at the moment, embodied impacts, is quite complex, and there's conflicting views. Again, at the AECB talk, we were putting this good example is timber. So depending how you do the accounting, some people see timber as a negative thing. So, and that leads to the idea that the more you put in the building, the lower, because you're locking up carbon, the lower the embodied, even to the point that your building it's not emitting carbon until 10 years into the future, when the operational is overtaken the embodied. Now, we think that's nonsense. We think, most of our buildings do use timber, but we don't see that as negative. It's still, every time you cut down a tree and turn it into a building, carbon is emitted. I'm not an expert on this, but I'm assuming there's less emitted than if we use steel or masonry and so on. So that's why we like to use timber. But we don't see it as negative. You can't, as someone on Twitter said, you can't log your way out of climate change or log away to sustainability. That was Scott Hedges on Twitter, was a nice quote. So I think the fact there's such a big gap not in the science is straightforward. It's more the accounting. It's how you decide where you draw your boundaries, like with the biomass discussion. If you draw your boundary around your Austrian wood stove and exactly enough forest to sustainably grow the fuel for it, then it's zero. But if you just draw it around your building, then like tonight we've put wood on the fire, we're now emitting CO2. And if we didn't light it, we wouldn't be. So if we sat here cold or we managed to stay warm another way, then we wouldn't be emitting CO2. And that's kind of obvious, but it's it's not obvious if you draw the boundary around exactly the right amount of woodland. Because
you sometimes hear about offsetting. I don't know whether that's a similar discussion, that people will say this is zero carbon or that's zero carbon, and you just think, not quite so sure.
We've got to do offsetting in the sense that we've got to plant loads of trees and we've got to do all that stuff, but we can't do that instead. We can't sort of say, I fly to America and plant a tree, and that's fine. We've got to do the not flying to America and the planting the trees and the not using the energy. We just can't. There's not enough offsetting possible. It's like with the biomass. Yes, it is on one level. It is zero carbon. You plant the tree, you burn the tree. The net result is zero. The thing is, there's just not enough trees can be produced to do all the things we need to do with that, including building, flying, running vehicles, heating our homes, making electricity and so on. So, if there was enough biomass to do that on the planet, then yes, it would be zero, but it's a tiny proportion.
And I know that lean production, so that you're almost getting your buildings, but you're using the minimum amount of materials to get you there. I mean, that must be a step in the right direction.
That's a good, that's the thing. That's definitely a good thing. Again, unless you're of the belief that the more timber you can cram into the building, the more negative carbon it is. But if you don't believe that, then the simpler the building, the less structural components, the less stuff, the less whatever it is, the cheaper it is as well. As long as that cheapness isn't cheap because you've used stuff that's been taken out of the ground as cheap oil and turned into products in China, that's cheap for other reasons. But if it's cheap because it's stuff hasn't had to have much processing, hasn't travelled far, there's not much of it, it's not highly processed, then that's a win-win situation.
Now, you had one slide in this presentation that I've written down the whole slide because I thought it was so interesting. It's the questions now. Actually, we've talked about embodied carbon, so I won't go there, but low carbon heat versus retrofit.
Well, this is the challenge. Most of my work is new buildings, and that's partly because I'm lazy and that's relatively easy, and because it frustrates me that the new buildings of today are being done so badly that they're becoming the retrofit of the future. But the big challenge is we've got all the existing buildings, whether it's housing or commercial buildings, whatever, and that's got to be dealt with. So there's a bit of a thing, do you retrofit them all to the Passive House standard, which seems incredibly difficult, particularly with listed buildings. Some buildings, if you've got a row of sort of ugly, mouldy concrete buildings that desperately need a lick of paint and stop the rain coming through the roof and so on, they're ready for a major refurb. It's no big deal to add some insulation. They'll need ventilating properly, add some good ventilation. The windows will be shot. You may as well put in triple glazing. All that's a bit of a no-brainer if you're doing that. But a lot of the retrofit isn't like that. It's perfectly good buildings that are sound and are going to cost almost as much as building a new building to raise them to that sort of standard. I genuinely don't know what the answer is. On very dense areas, you could look at piping low carbon heat. How do you create that low carbon heat? Again, we're saying biomass doesn't work. Large heat pumps and so on. The distribution losses become huge.
And also this carbon burp that theoretically could happen if we did retrofit everything.
Yeah, but again, if you just see sort of sound bites on Twitter, it's easy to lose the plot and suddenly think, gosh, we mustn't do anything because we do have to emit some carbon to save carbon. We can't. We could just live colder and not travel and do all that. But if that's not going to happen, then we're going to have to build wind turbines and so on. We're going to have to insulate. We're going to have to improve buildings. But it may be, the trouble is there's such an emergency and it doesn't sink in. It hasn't sunk in for me. That's another point I think this last year, particularly with the school strikes and Greta. I was in Sweden recently, a conference there, and again, it's very much the discussion with this urgency, because I've been doing this stuff since the 1980s and it's a good job and it feels like you're doing good stuff, you're not destroying the planet, but it's been like a sort of a comfortable career, and actually it is so urgent. We do need some really radical solutions.
And things like that retrofit, it just seems to be going at an absolute snail's pace. It's not as if you can look at the facts and think, well, if we can just speed up, it's as if we can just get started.
Yeah. Well, I suppose it's, again, a bit like the new build. The thing that's really depressing is when stuff's done and it's done badly, because it probably costs more to do it badly than to do it well sometimes, or someone's had scaffolding up to re-render their building but they haven't insulated, or they've had scaffolding up to put PV on the roof and the roof's almost shot and the roof could have been upgraded. So that missed opportunity of when refurbishment needs to happen. So that's one thing. So that's kind of that should be a win-win thing, but it's not everything. And then there's going to be stuff that's just too hard to do. And I mean, as a child, we grew up in a very cold, remember the 1970s, the oil crisis, living in a very cold cottage in Essex, impossible to heat it in winter. So we just lived in the kitchen, and it was warm and cozy in the kitchen, but we had to live differently. We couldn't dream of heating the whole house to 20 degrees. And so we really had to wrap up. And when we're designing stuff in my professional work, that's not something we say to people, oh, you need to wrap up. But if you really haven't got the money, and if we're not going to be investing as a society into it, then I don't know what else you do.
And that was another thing on this slide, was about adapting for climate chaos. Let's say we sit back and do nothing, which seems like it is something that could happen, how we might adapt in that scenario.
I think that's really dangerous, and it's another one of these paradoxical things, is we've got to do it, but we mustn't do it. So, I'm happy to think we should be making buildings robust enough. We maybe talk about higher wind speeds, but that doesn't hurt to design your buildings well for slightly higher wind speeds now. But to start designing for much higher temperatures or rising flood, it gives you a false sense of security, thinking you can survive this by making. But people are already saying we want you to use future climate data with warmer summers. It's kind of it's not going to be the problem that you're a bit sweaty in summer. That isn't going to be the problem. Once the comfort becomes a problem, other things are going to be a problem. You've got to design for weather now, so we get really hot summers. So we'll happily design for an extreme summer now, and they may get more frequent and so on. But if we're talking about designing buildings that will adapt, that's really dangerous. The people on their islands. George Monbiot did a good skit on this on Frankie Boyle, which I won't try and remember and repeat, but it was very good. It's just the millionaires are on their islands, sort of thinking, how are you going to pay for security guards when money has no value? That's not what I want to think about.
Is this your line about are we going to have Sweden or a version of Mad Max?
Peter Harper, I'm sure he said that, where he denies ever saying it, but it's this idea of what we want the future to be like. Sweden or Mad Max. But the problem with that is, as I said at the AECB talk, the Mad Max thing, it's kind of strangely romantic. People don't think it through. It's like it's a survivalist thing. People going to the hills and thinking, come Armageddon, whether it's political breakdown or some sort of religious thing. You get this in the green movement, you get it within religious communities. It is pervasive, and I think it's been around for thousands of years, this idea of sort of cleansing of the earth. And on some weird level, it sort of appeals, either it's a romantic idea of going back to simpler times and living off the land and so on. And it is romantic, and we kind of did a bit of that in the 80s. But if you actually think it through, it's anything but romantic. It's Mad Max.
I've gone through all your other questions now that you were mentioning, but I didn't put this one in, and I think it is worth mentioning because it's really about attitudes, and that's how can we actually change the trajectory of industrial society? And again, I'm not sure, you're not going to have an answer for me, but...
No, Alan put that in as a bullet point on the slide as a sort of, what do you do? That is an option, but it's just like we could, world peace is possible tomorrow. We just got to, it's very easy. We just need to all not kill each other. It's so simple. It's never going to happen. So it's, I really don't know. We put that in as saying, look, these are the options. So that I don't see, I would say it isn't an option. Things can change incredibly fast. This last year, things have gone good and bad. They've changed fast. We've got rise of the fascism, and we've also got huge awareness in climate issues and so on. So who knows? It's very hard to predict even 1 year ahead, isn't it? And I'm not in the game of predicting stuff. But that's what keeps us going, I suppose, is thinking that at least we're doing the right thing. On one level, incredibly pessimistic, so absolutely can't see any way this is going to end well. But at the same time, what else do you do?
As we look at 30 years of the AECB and how you wanted to reflect on it, was there a final message to come out of this, or a final message for people building buildings maybe?
The AECB conference, it was different to usual. It was a bit of a celebration. It's a bit of an in-group. It was in-jokes. It was, people have known each other for a long time. So it's kind of a niche thing. So it's sort of a little bit strange talking about it. Although it's a completely open, anyone can join the club. It's friendly, and, it's really not a clique. But it was very much that event. I was sort of seeing in those terms what we've been doing, how there's various convergences of ideas and so on, but also and how AECB as a tiny organisation has actually had, in a modest way, fairly big impact. Is if you look at some of the best performing buildings around now, you'll see AECB members were involved in most of them. That's why Alan just did a quick check of, what independently what are considered sort of particularly green buildings, and I can't remember the proportionates on the presentation, but most of them were AECB members involved. But then you look at things like I just looked at the World Green Building Council website the other day. I thought, that'll be interesting. It had sort of exemplar buildings. And so I looked, and there was a few dots in Britain, and they were just people who had paid to have membership. There were no buildings mentioned. There were certainly no passive house buildings. There were none of the buildings that AECB members would think were exemplary. So, we're within our little group. We're kind of, it feels like things are moving forward. But if you step out of the bubble, then, it feels like it's unknown what we're doing. And
well, I felt, as someone who is not within the industry as such, but just looking at it, it really told the story of progress. You could see it as you looked at that whole presentation. So I'm going to give you a pat on the back, even if you're not going to. So, Nick, thank you very much.
Oh, thank you. I mean, progress is huge, but it's tiny at the same time. So, pessimistic optimism.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/282, where we've got our summary of all the key points once again, a few photos in there as well. Clearly, we're going to have links to Nick and the AECB. If you've got a comment or you'd like to ask a question, you can do that within the show notes or tap us up on social media. Everything you need at houseplanninghelp.com/282. Finally, today, if you're one of our Hub members, just reminding you, there's another video to check out in the Hub. This is from my own build, and we're getting a good way through. Although, just reflecting on this particular time, because everything, it feels like all the main work's been done. All the air tightness layers are complete now. They're lime rendering, putting that final coat on the outside, starting to deal with some of the landscaping as well, and thinking about the service connections. So all these things are happening, yet in real time, as the client, things seem to slow. Just, are we not there yet? Are we not there yet? There are just so many little things that need to happen that perhaps we don't see because the building looks like it's there and all the main work's been done. But yes, lots of things to come. So have a look at that one. If you want to find out more about the Hub, houseplanninghelp.com/join. Next time, Tim Martell is my guest as we look at how pH Ribbon is helping us get more intentional about the embodied carbon of our projects. It's a plug-in to PHPP. So that and more next time. Thanks for listening. The House Planning Help podcast is produced by Regen Media. Content that matters.